Imagine a world where complex problems can be solved in seconds, not years. Welcome to the exciting realm of quantum computing, a radical departure from the classical computing we're all accustomed to. Instead of the binary ones and zeros that traditional computers use to process information, quantum computers operate on quantum bits or qubits, which can exist in multiple states at once, thanks to a peculiar quantum property known as superposition. In practical terms, this means a quantum computer can process vast amounts of data simultaneously, exponentially outpacing the capabilities of even the most powerful classical computers. This revolutionary technology has the potential to unlock new frontiers in everything from climate modeling to drug discovery, and from financial modeling to artificial intelligence. Sounds like science fiction, right? But the truth is, we're closer than ever to making this a reality. To understand where we're going, we need to know where we've come from. Quantum computing, while seemingly a product of the 21st century sci-fi, actually finds its roots in the early 20th century with the birth of quantum mechanics. Our journey begins with the likes of Max Planck and Albert Einstein, who dared to challenge the status quo of physics and introduce the world to the strange, yet fascinating realm of quantum mechanics. This field of study paved the way for the concept of quantum computing, but it was decades before this concept would evolve into something more tangible. Fast forward to the 1980s and the world saw the first glimmers of quantum computing's potential. It took a visionary like Richard Feynman to propose that a quantum computer can outperform any classical computer by simulating the natural world. However, it wasn't until the 1990s that the first quantum algorithms were developed. Peter Shor, a mathematician at Bell Labs, developed an algorithm that could factor large numbers into primes exponentially faster than any known classical method, a feat that could potentially render the encryption methods of the time obsolete. This sparked a surge of interest in quantum computing, leading to the development of the first quantum computer prototypes in the early 2000s. Companies such as IBM and D-Wave Systems began to experiment with quantum bits or qubits, the fundamental building blocks of quantum computers. These early prototypes were rudimentary, only able to process a handful of qubits, but they represented the first steps towards harnessing the power of quantum mechanics for computation. Fast forward to today, and the race to build a truly functional quantum computer is on. Quantum computing has come a long way from its conceptual birth in the early 20th century. As we continue to push the boundaries of technology, the potential for quantum computing seems limitless. With the ability to process complex calculations faster than any classical computer, quantum computing stands to revolutionize technology as we know it. Fast forward to today, and the race to build a truly functional quantum computer is on. In the world of technology, the phrase "race to the top" takes on a whole new meaning. Now let's shift our focus to the major tech giants who are neck and neck in the quantum computing arena. These include the likes of Google, IBM, and Microsoft, each with their own unique approach and strategy, each with their own milestones and achievements. First off, we have Google, who in 2019 claimed quantum supremacy with its 53-qubit Sycamore processor. They stated that their quantum computer performed a calculation in 200 seconds, a task that would take the world's fastest supercomputer 10,000 years. A truly remarkable feat, if you ask me. Next up, we have IBM, a pioneer in the field of quantum computing. IBM has been in the game since the early days and has made significant strides in the development of quantum systems and software. They made waves in 2021 when they unveiled their 127-qubit Eagle quantum processor, their most powerful quantum system to date. Last, but certainly not least, we have Microsoft. Microsoft's approach to quantum computing has been slightly different, focusing on a theoretical particle called a topological qubit. While they have yet to showcase a working quantum computer, their groundbreaking work in the field of quantum algorithms and software development is pushing the boundaries of what is possible. Each of these tech giants is tackling quantum computing in their own unique way, and each is making impressive strides. They're not just racing against each other, but against the limitations of technology itself, pushing the boundaries of what we currently know and understand. While the finish line is still a ways off, the strides these tech giants are making are nothing short of impressive. The quantum race is on, and it's a thrilling spectacle to behold as we witness the dawn of a new era in computing technology. So what can a quantum computer do that a traditional computer can't? It's a question that's been on the minds of many since the advent of this revolutionary technology. You see, unlike classical computers, which perform operations using bits that are either in a state of 0 or 1, quantum computers use quantum bits or qubits, which can be in both states at the same time. This phenomenon, known as superposition, allows quantum computers to perform multiple calculations simultaneously, vastly outstripping the capabilities of even the most advanced classical computers. Let's delve into specifics. Consider drug discovery, a process that often requires exploring a vast number of molecular combinations. For classical computers, this is a daunting task. But quantum computers, with their ability to hold multiple states and perform simultaneous calculations, could significantly expedite this process, potentially leading to quicker discoveries of life-saving medicines. Next, let's look at climate modeling. Predicting the future of our planet's climate involves processing massive amounts of data and complex simulations. Here again, the power of quantum computing could be transformative. By processing and analyzing data at unprecedented speeds, quantum computers could enhance the accuracy of climate models, thereby providing us with better tools to combat climate change. And of course, we can't forget about cryptography. Today's encryption systems are based on complex mathematical problems that classical computers would take thousands of years to solve. But quantum computers, with their superior processing power, could crack these codes in a fraction of the time. While this poses new challenges for cybersecurity, it also opens up new possibilities for developing unbreakable quantum encryption systems. It's clear that the potential applications of quantum computing are vast and varied. But remember, it's not just about speed. Quantum computing represents a paradigm shift in how we process information and solve complex problems. Quantum computing isn't just faster computing, it's a whole new way of thinking about the world. So, what does the future hold for quantum computing? It's a question that sparks both excitement and curiosity. As we delve into the realm of quantum possibilities, it's clear that we're standing on the cusp of a new era in information technology. Currently, quantum computers face some significant challenges. For one, quantum systems are extremely sensitive to their environment. The slightest disturbance can cause what's known as decoherence, disrupting the delicate state of quantum bits or qubits. This sensitivity makes it difficult to build and maintain a practical, large-scale quantum computer. Yet every challenge presents an opportunity for innovation. Scientists and engineers around the world are tirelessly working to overcome these hurdles. Breakthroughs are being made in areas such as quantum error correction and quantum algorithms, which can help mitigate the effects of decoherence and make quantum systems more robust. But what does this mean for society and the economy? Well, the implications are vast. For instance, quantum computers could revolutionize the fields of cryptography and data security. They could also make significant strides in drug discovery and climate modeling, helping us tackle some of the most pressing issues of our time. Moreover, quantum computing could spur a new economic boom. As industries adapt to this technology, we could see the creation of new jobs and a surge in economic growth. However, it's important to note that this is not an overnight change. It will take time for quantum technology to mature and integrate into our daily lives. We're still in the early stages of this quantum journey, but the momentum is building. So as we look towards the horizon, we see a world transformed by the power of quantum computing. A world where complex problems are solved in the blink of an eye, where our understanding of the universe expands and where technology takes us to places we've never been before. Quantum computing has the potential to revolutionize our world. And while we're still in the early days, one thing is clear: the quantum future is coming. Quantum computing is more than just a technological advancement, it's a paradigm shift. It's a leap forward that takes us beyond the realm of classical computing, opening up a universe of possibilities previously only dreamed of. We've journeyed through the annals of quantum computing from its inception to the present day. We've seen how companies are racing to harness its power, and we've glimpsed the quantum future that awaits us. This technology has the potential to transform our world, from solving complex problems that are currently beyond our reach to revolutionizing the fields of cryptography, medicine, and beyond. It's not just about faster computations or more efficient algorithms. It's about a whole new way of thinking, a whole new way of interacting with information and with the world around us. So as we stand on the precipice of this brave new quantum world, we have to ask ourselves, are we ready for the revolution?